We have seen previously that the two-pointer approach brought efficiency, for example, to the pair sum problem. The question now we have is how do we apply that idea to, let's say, this problem, the carpet area problem? How do we set these pointers? How do we make them move? Because remember, for the two-pointer technique, we need a very clear rule to make the pointers move. However, the guiding light is still the same. Just like in a sorted list, we knew that, when I have a given sum, what do I need to do to increase the sum or decrease the sum? Basically, move the left pointer or the right pointer, let's say. In the same way, we will come up with a rule which will avoid redundant computations. So, which means that we will not test all pairs of lines. We will just test those where we can potentially increase the area. So what I'll do is to first describe the algorithm in words, and then we will look at some illustration of it, and then we'll see why this illustration makes sense and what is the intuition behind this before we start to code. So we'll start with two pointers at the extreme locations. Let's say so at 0 and length of L minus 1. Remember, L is that list which contains the length of those lines. I'm going to refer to the two pointers as JJ for the left pointer, KK for the right pointer. For this, let's say, location of JJ and KK, I will calculate the area, which remember is given by minimum of LJJ and KK. So the smaller of the two lines multiplied by KK minus JJ. Notice I am putting the right pointer as KK, left pointer as JJ, which means that KK by definition is higher than JJ, and that's why I have not put the absolute value, and just a bracket is fine. But nonetheless, I will compute this metric. Now we'll store this metric so that we have a reference. Then we'll ask ourselves, is LJJ less than or equal to LKK? Notice I am, looking at the length of those lines of the list. If the left guy is smaller, then I will move the left pointer inwards. Yeah, we'll see why this works, why this is logical. If the left guy is bigger, or in other words, if the right guy is smaller, I will move the right pointer one step to the left. Notice left pointer moves to the right, right pointer moves to the left. So I will get another set of KK and JJ from which I will find the area, and if it has increased from the previous one, then I'll note that. And I'll keep doing this until my two pointers meet. Now, this is a pretty interesting algorithm. Let's see this in pictures so that we can understand this a bit more clearly. Let's say this is my list now, not to scale, but just to illustrate the idea. So I will, put my two pointers, like I said, on the two extremes. So here, and I'll compute the area. So whatever area is coming, now I'll kind of store that in, let's say, a variable. Now I will ask myself between these two lines. So this, remember, is LJJ, LKK. Clearly LJJ is smaller. And since that is the case, I will let the right pointer be. So right pointer stays wherever it was, but I will move my left pointer inwards. Now I come to this level, again, I compute the area. This time around, I notice that, so I update my area. If it's more than the previous one, I update, otherwise I let it be. But this time round, I notice that my left is still smaller than the right. Look, we are just looking at the length of the line. Left is smaller than the right, so I move my left inwards again. In fact, I do that once again, but notice here what happens. I have, a situation where my left line now is taller than the right line, and in this case, I'm going to move my right pointer inwards. And in fact, this is the last computation that I'll make. And I will basically at this point, because any movement is going to bring the pointers together, right? So I will at all these steps keep finding the area and keep updating. If the area is bigger than the previous one, I would have, updated that. And believe it or not, this approach would have given us the max area. Now, why is this working? Let's try to build some intuition around this. So the question we are asking ourselves is, why is it that if I move my shorter pointer inwards, the pointer pointing to the shorter line inwards, why is it that I'm moving in the right direction? So let's look at this carefully. Yeah, basically, let's ask ourselves what exactly happens when I move any of the two pointers inside, the left or the right, right? So remember, the area is minimum of these two lines multiplied by the base. So when I'm moving, you know, um, any pointer, so I'm showing you for the left pointer, but the idea is the same for the right one. But if I'm moving the shorter pointer inside, or any pointer inside for that matter, the base of this becomes smaller clearly, right? Because I've got one lesser item to look at, yeah, which means that the area can still increase provided the height becomes larger of the two. So let's see it more carefully. Basically, if the change in height compensates for the width loss, then we are doing it well, right? So for example, let's take this as an example. Let's say this was situation. So I move my left pointer. It turns out that these two are of equal length. Well, I know that the area has decreased because the area is a function of minimum of these two. That did not change, but the base changed, right? So basically area has decreased in this case. On the other hand, in this situation, I may increase the area because this line is now bigger than this line, so the area starts to dominate. Area starts to get dominated by this line, right? So base has increased, but perhaps the change in the the difference of the lengths compensated for it. So area in this case would increase, whereas if this was smaller, area would decrease because look, the area will be dominated by the smaller of the two, right? Think about it. The point I'm trying to make is that when I move my shorter height pointer inwards, there is a possibility, there's no guarantee, but there's a possibility that the area might increase. On the other hand, if I were to take my taller pointer, I mean the pointer pointing the taller or longer line, if I move that inside, well, I am guaranteed to only decrease the area. Why is that? Well, think about it. Let's say this was the situation. I move this guy inwards. This height really doesn't matter. It was a taller of the two because this height is going to dominate the area. So what happened here? From here to here, well, the base became smaller. This did not change, so the area decreases. Even if the line were to become longer, the area will only decrease because the area is dominated by the shorter of the two, by the smaller one, right? So the area decreases here. Obviously, in this case, the area will decrease even further because now the area will go not dominated by this, but in fact dominated by the shorter of the two, which is this. So area will decrease even further. So the point is this, right? When I move my shorter of the two pointers, there is a possibility, but when I move, if at all I were to move the longer of the two pointers, I am guaranteed to only decrease the area, which means that the algorithm can work by just looking at the shorter of the two, moving the shorter inwards. And in this process, if you think about it, we are just eliminating many redundant computations. We are just moving in the direction where I can potentially see an increase. I'm not, let's say, computing those areas where I'm bound to, for example, let's say, decrease the area. So, for example, just to illustrate, in this case, we are computing the area bounded between the extreme lines. I'm never computing the area bounded between this and let's say this because clearly this is going to be small, right? So in this way, if you think about it, we are reducing redundant computations. We are removing them from the picture. We are moving in a smart way so that there is a potential that I've increased the area. If it increases, well and good, I update. If it doesn't increase, also doesn't matter. But I went in the right direction, right? So I can keep applying this rule till the time the two pointers meet, and that is the end of my algorithm. Very beautiful. Think about it. Happy to discuss. But work through some examples and convince yourself that moving the shorter length pointer inwards is the right way to do. Look at our website www.refibyte.in because we have a lot of such material through which we learn programming, Python, algorithms, and have a lot of fun. Take care. Thank you so much. Bye bye.